lesson is over. CPCTC, corresponding parts of congruent triangles are congruent. So the objective, you guys will be able to prove angles and segments in two triangles are congruent by first proving the triangles are congruent and then using CPCTC. So let's do a little bit of review before we get into the CPCTC. Name and mark all the pairs of corresponding sides and angles in the congruent triangle. So since the triangles are congruent, that means angle N is congruent to angle T, angle M is congruent to angle V, and angle L is congruent to angle U. I like to mark those angles out first before I do the segments because I think it's a little bit easier. But then NM is congruent to TV, NL is congruent to VU, and NL is congruent to TU. So since the triangles are congruent, that means their corresponding parts are congruent, angles and sides. Say that one more time. Since the triangles are congruent, that means all the corresponding parts are congruent, all three angles and all three sides. So just to get into that, that's what we learned already. If the sides and the angles of a triangle A are congruent to all of them in triangle B, then the triangle A is congruent to triangle B. So that's what we talked about at the very beginning of this chapter. If all the angles and sides are congruent in angle A to all the angles and sides in triangle B, that means that those two triangles are congruent. But it also works the other way around. If I know the two triangles are congruent, then that means all the angles and all the sides are also congruent. I think we did both of those. I think that was back in lesson 1. So this is kind of what we're getting into without going into too deeply. If I told you, I gave you these two triangles, and I want you to prove that angle K and angle O are congruent. So this angle and this angle. I want to prove that they're congruent. Well, the only way to do that, there's no way to do that besides if we first say that the triangles are congruent, well, that means all the angles and all the corresponding sides are congruent. So that's what we're doing today. Today, to prove those two angles are congruent or to prove that those two parts are congruent, you have to prove that the whole triangle is congruent first. So I know that triangle K, we'll do it that way. KJL is congruent to triangle O and M. I know that because of side, angle, side, side, angle, side. So since I know that those two things are congruent, that means all the other angles and all the other sides are also congruent. So that means K and O are congruent. That's what we wanted to prove. And the reason is because corresponding parts of congruent triangles are congruent, CPCTC. So literally, that's the lesson for today. All of it, all in one thing, doesn't look too bad. So just to make sure I reiterate, that means corresponding parts of congruent triangles are congruent. So if two triangles are congruent, then all the pairs of corresponding sides and angles are congruent. That's what that means. So again, for all these times, for all these proofs that we're going to do, or all these examples, we're going to first prove that the triangles are congruent. Then it just takes one more step to say angles or sides are congruent. So this is what we're going to be doing a lot today. We're going to say that they're congruent, and then we're going to list all the other corresponding parts that they don't list in our figure. So first, we need to prove that these are congruent. So use the mark diagram to state the method used to prove the triangles are congruent. Name the additional corresponding parts that should then be concluded congruent. So that doesn't tell you to do this, but I'm going to go ahead and say triangle DAY is congruent to triangle BYA. I like to start with that congruent statement. And the reason is because, well, we have a side and a side. We have the angle and the angle, but then we also have this side is congruent to itself. So you don't really need this, but I want to add in there AY is congruent to AY, and it's the reflexive property. I would add that in your notes if I were you. because that's going to help you. We use the reflexive property a lot. So that means we know this by side, angle, side. So what else can we say is congruent? Well, I know that BY is congruent to BA. Those two segments, they're not marked as congruent, but they are. I know angle D is congruent to angle B. And I know angle DYA is congruent to angle BAY. And again, it doesn't really ask for this reflexive part, but I like to put that in there. It's good practice. Honestly, I think these are harder than the proofs, because the proofs you only need to do one pair of corresponding parts, whatever they're looking for, and not all three of them. So again, I know that triangle TUA is congruent to triangle VUA. And I know that because of angle, side, angle. We have angle, side, angle. So let's see, we have angle T is congruent to angle V. We know that since they're congruent. I know TU is congruent to VU. And I know TA is congruent to VA. Again, don't make this harder than it is. You're just proving the triangles are congruent, and then after that, all the other corresponding parts have to be congruent. So this one we have a triangle VTY is congruent to triangle WYX. And the method would be angle, angle, side. The side is not in between the angles, so it's a little bit different than we did earlier. So the corresponding parts. I know angle V corresponds with angle W, so they are congruent. I know VT is congruent to YW. And I know TY is congruent to YX. So remember, you always need to prove triangles are congruent. You always need to prove that the triangles are congruent before you use CPCTC. So name the postular theorem that you can use to show the triangles are congruent, and then explain why the statement is true. So I want you to explain, why is EA congruent to MA? How can we explain that that's true? But again, the first thing we have to do, since we don't know anything about segment EA or MA, we don't know, we have to prove that the triangles are congruent first. So again, this isn't exactly a proof, but we're getting closer to that. So I know that TA is congruent to TA, and I know that because of the reflexive property. It's the same line, so it's reflexive. So that means I know side, angle, side. So that means with side, angle, side, I know the triangle ETA. Whoops. ETA is congruent to triangle MTA. And how do we know that? Well, I just said with side, angle, side. So now that we know that, now we know all the other corresponding parts have to be congruent, which is why we know EA has to be congruent to MA. EA is congruent to MA, and I know that because corresponding parts of congruent triangles are congruent, CPCTC. Now again, I know I wrote that a little bit more like a proof, but that's because that's where I'm going. So I know this isn't actually technically a proof, but that's what I want you guys to get used to. That's what we're going towards. So I want to make sure I kind of write it with that in mind. Triangle hey is congruent to triangle man by, so triangle HUI, triangle MAN, so we have side, angle, angle, which is angle, angle, side. And again, it's congruent to these over here. So that means angle H is congruent to angle M. I know HY is congruent to MN, HY, MN, yep, just to make sure. And EY is congruent to NA. It doesn't matter what order you put the segment letters in, or angles, really, once you get to angles where you need 3 letters. But the triangles, you do need to be careful. So same thing with this one. Triangle CAT is congruent to angle RAP. Triangle CAT is congruent to triangle RAP. And I know that because we have angle side angle, which means I know that angle T is congruent to angle P by CPCTC. I know CT is congruent to segment RP by CPCTC, and TA is congruent to PA by CPCTC. Again, this is really basically one thing that we're just getting a lot of practice with, so it shouldn't be too bad. Now for the next ones, we need to do these 3 things, but it's the same 3 things we've been doing. First off, list all the information that you know that you can prove the triangle's congruent and why. So the first step is doing this stuff like vertical angles, reflexive property, and we're doing stuff that we need to get us started on part B, where we know the triangles are congruent. So part B is where the triangles are congruent, so we write the congruent statement and we say why. And then C is list all the other sides and angles. So it's the same thing we've just been doing. And then it says and Y, which is always going to be CPCTC for this lesson. So they say AC is congruent to AR, so AC is congruent to AR, and angle 1 and angle 2 are congruent to each other. So step A is saying, okay, so we need to know that this angle and this angle are congruent because they're vertical angles, which make them double angles. There you use single arcs. So that means triangle CAL is congruent to angle RAL. Sorry, I think it's a triangle instead of angle. Angle CAL is congruent to triangle RAS. I did it again. Angle RAS. My apologies. And I know that because of vertical angles. Vertical angle theorem, or if you just put vertical angles or vert angles, whatever you need to do, the ones I know. So now, since we know that, that means I know that the triangle CAL is congruent to the triangle RAS. Oops. And I know that because angle, angle, side. So angle, angle, side. And so what are the other things that we know? I know angle 3 or C, whatever you want to call it. Angle 3 is congruent to angle 4 or R, whatever you want to call it. I know CL is congruent to RS. And I know LA is congruent to FA. Same thing with this next one. The angle NLM and LM is congruent to LNO. And OLN is congruent to M and L. So the other thing we need is that LN is congruent to LN because it's the same line. LN congruent to LN. And again, that's a reflexive property. That one, between that and vertical angles, those are ones we use the most in this section, or this chapter, I would say. So then that means triangle O and L. Doesn't matter what order you put that in, but then it's got to correspond M, L, N. And I know that because angle, side, angle. which then means angle O is congruent to angle M. LO is congruent to NN. And LM is congruent to ON. Now, this might be a little bit different in your notes, depending on what year you're watching this, because this wasn't a proof, but I made it a proof. And all I did to make it a proof, so in your notes, you don't have to do anything. You don't have to erase it all or tear it up or anything. All I did was I added this one line. Everything else is the exact same. So if I know if the given is that AB is parallel to DC, and so they marked that for us, and I know angle B is congruent to angle D, they marked that for us, can you prove that AD is congruent to CB? Now, again, I'm telling you, this is exactly what we've been doing. Since they're two triangles, we can't tell anything about those segments, so the first thing we have to do is try to prove that the triangles are congruent. So since I know AB and DC are congruent, we can act like this is a transversal. So we have this angle and this angle are congruent because of alternate interior angles. Now, a lot of people then try to say, so this angle and this angle are congruent, but that's not the case because I don't know if DA and DC are parallel. They look parallel, but we don't know yet. They don't tell us that, so you have to be careful with that. So then we also know, so I guess I should start with, I know angle BAC is congruent to angle BAC is DCA, and I know that because of the alternate interior angle theorem. Again, if you want to do the whole fancy thing with the biconditional and whatever, you're more than welcome to. I know most teachers are still making their kids do that. As long as I know you're talking about the alternate interior angles, I'm okay with that. So that still doesn't give us enough information. We only know two angles. We need one more bit, and that is this. AC is congruent to AC, and exactly like I said earlier, that shows up a lot. That's reflexive. So those pieces of information tell us that triangle DCA is congruent to triangle BAC, and I know that because of angle, side. And this is where a lot of students stop, but you can't stop yet. We still need to prove this. We still need to do one more step. A lot of people did that on their last test where they just didn't do the last part of their proof, the last single thing. We still need to say, so that means AD is congruent to CB, and the reason why, CPCTC. Now, again, it's very similar to what you did, what you had in your notes if you had to change, or I guess I should say, it's very similar to what we were doing. The only difference is at the very end of these, I listed out all the stuff that's congruent, and this one, I just had to list out what I knew or what I was trying to prove, rather. So same thing with this one. It says MP bisects LMN. So MP, this line, bisects this angle. When it bisects it, remember that means that the angles are cut. The angle is cut in half, so they are congruent. So I had angle LMP is congruent to angle NMP, and I know that because the definition of bisect. Technically, it's the definition of an angle bisector, but either one is fine. I'm okay with that. It might actually help. We have enough steps. It might help to number these. I know I didn't do it on the last one, but it's a good habit to get into. So then the next thing, I know that, I guess the other given that they say is LM is congruent to NM. LM is congruent to NM. So if you want to list that, you can. Since it's a given, again, this is an informal proof that we're still sticking with. So if you don't want to put that, it's okay, but you will get some points for that. And lastly, I know PM is congruent to itself. PM is congruent to PM. And I know that because it reflects it. So now I know the three things. I know two sides and an angle. Hopefully they're in the right order. And they are. Side, angle, side is exactly what we want. So triangle NMP is congruent to triangle LMP. And I know that because of side angle side. And again, we're not done yet because I wanted N and L. I wanted to prove that these two angles were congruent. Well, if the two triangles are congruent, that means all the corresponding angles and sides have to be congruent. So N has to be congruent with angle L, CPCTC. So that's what the proofs are going to look like for this one. And again, I should have numbered them. I should have numbered this one. You don't have to, but it's a really good way to stay organized. So I should have said step 1, step 2, step 3, step 4. Again, not a requirement, but definitely helpful, especially once we get ones that have more and more steps. So that is the end of the notes. This is important. You're done with the notes now. So if you have anything else you need to work on, worksheet, exit ticket, whatever, you can go ahead and work on that. But if you want some extra practice, if you have time, you can watch these next 10. So this video is going to look really long, but it's a little deceiving because I'm going to do 10 extra problems. So, and this is kind of a review from the last several things we've done. So draw a triangle ABC. Make sure you don't draw, whenever you draw a triangle, try not to make it really small, especially in this one, BD, so that it bisects ABC. So now, if you draw it too small, it's really hard to see this. That's BD, and it bisects, which means these two are congruent. So what can we conclude? That's what we conclude. I can conclude that angle ABB is congruent to angle CBD. And the reason because the definition of bisector, or just bisect is fine. Look at another one. Draw XT. That is a segment, XT. Put P so that it's the midpoint. So P is right here. Since it's the midpoint, that means XT and PT are congruent. That's the whole idea. If you cut it in half, then both sides are congruent. So again, what can we conclude? Same thing. XP is congruent to PT. And I know that because of the definition of midpoint. Now, just to get technical, P is not a bisector because P is a point. A bisector would be if you have a segment or a line that goes through. So a segment can go through the midpoint, and that's what makes it bisector. But again, that's just kind of being technical and nitpicky. Honestly, if you would have said P is a bisector, I probably would give you points because not exactly right, but you have the right thought process. Practice marking diagram. So draw a triangle ABC and XYZ. Now, I'm not sure, but I would bet we're going to do something with congruence, so I'm going to try to mark them so they look pretty similar. And again, we do have to make these congruent, it's nice that you put them in the same order, so it's not like upside down or anything crazy. So mark the triangles so you can prove they're congruent by side, side, side. So that means AB is congruent to XY. BC is congruent to YZ, and AC is congruent to XZ. Develop and prove. Tell how the two triangles are congruent. Give a congruent statement, and then list all the other corresponding parts. So this is the same thing we were doing earlier. So we have triangle KLJ is congruent to triangle OMN. And I know that because of side angle side. So since we know that, that means that angle K is congruent to angle J. Angle K is congruent to angle O. My apologies. Angle J is congruent to angle N. And the segment KJ, drawn really sloppy, is congruent to segment NO. So what is angle L if angle MKL is congruent to JET? So we actually did this in maybe a worksheet or a warm-up, or not, maybe you've never seen this. So I want to know what angle L is. Well, the problem is angle L and angle T are congruent, but we don't know what angle T is either, so we have to work a little bit. So J is congruent to M. They're in the same spot. So that means that is 85 degrees. So now I can solve for L by saying 85 plus 32 plus L is equal to 180. Again, if you want to make that an X or a Y, you're more than welcome to, but since it's angle L, it's not the best thing ever. But I like that because you can tell what it is. And you can make your variables anything you want, so might as well. Then subtract 117. L is equal to 63. So that's what we're looking for. Angle L was 63, so it's got to be 63. Given the diagram below, what can be proven congruent and why? So really, with this diagram, the only thing we can prove is that these two angles, because of the vertical angle theorem. So angle YEZ is congruent to angle GEF. Now remember, when you're drawing an angle, it doesn't matter what order you put them in as long as the vertex is your middle number, or sorry, your middle letter. But a triangle, it does matter the order. So I usually, when I do an angle, I try to make it so the angles correspond with everything. But you don't have to. It's just good practice to get into. But the vertex has to be the middle one. And I know that because of the vertical angle. What's the value of X if they are congruent? So again, this is another one where I know angle C and angle E are congruent because they tell us in this corresponding statement. So that means this is 81. So we have 81 plus 51 plus X plus 5 is equal to 180. So combine all your like terms. 81, 51, and 5 are all just normal numbers with no variables. So that's 137 plus X is equal to 180. Subtract 137. X is equal to 180 minus 137 is 43. And again, that doesn't mean that this angle is 43. That means this X is 43. So be careful with that. Given the diagram below, what can be proven congruent Y? So this one, really the only thing is VW. VW is congruent to VW. And again, we've talked about it a lot. That's that reflexive property. So I have done a problem similar to this, or I've done this problem for something, I don't remember. But there's one thing in here you can do two different ways, and I'll talk about it in a second. The first thing is, I'm going to solve for Y first. You don't have to, but I'm going to. And I know E and B are congruent, so I know that's got to be 42. So I know 87 plus 42 plus 3Y is equal to 180. So when you combine your like terms, that's 129 plus 3Y is equal to 180. Subtract 129. 3Y is equal to 51, and when you divide both of these by 3, you get Y is equal to 17. So now to solve for X, there's two different ways to do this. One of the ways, since I just did the first one where I added all the angles together and set it equal to 180, that's what I did the first time I saw this. So I said, okay, if Y is 17, then 3 times 17 is 51. So that's what this angle is, 51 degrees. Well, that means this one's 51. So I said, okay, so 42 plus 51 plus 5x, not 4, 5x plus 2 is equal to 180. You can do it this way. That's completely fine. Your like terms, 42, 51, and 2 is 95. So we have 5x is equal to, 95 plus 5x is equal to 180. Subtract 95, subtract 95. 5x is equal to 85. Divide both sides by 5. X is equal to 17. So that's one way you could do it. Honestly, that's the way I would have seen it, and I would have just done it that way, not thought anything of it. But there's actually a quicker way to do it, and that's to realize that angle D is congruent to angle A. So 87 and 5x plus 2 have to be equal. So 5x plus 2 is equal to 87. If you add 2, sorry, subtract 2, that was close. Don't go too quickly like I did. You make silly mistakes. 5x is equal to 85. Divide by 5. X is equal to 17. Sounds a little bit shorter, but they both give you the right answer. Last but not least, given the fact that Km bisects LP, what can we tell? So this is Km bisects LP. That means that Lm is congruent to Mt. Now again, you could say then that point M is the midpoint, but when you're talking about bisecting, it's got to be a segment or a line. So that means Lm is congruent to Tm. Why? That is the definition, and again, this would actually be the definition of a segment bisector, but if you just say definition of bisect, that's fine. All right, thanks for watching those extra practice problems. That should help you guys in the future. If you have any questions, don't hesitate to ask and or email me.